All right, well, hello everybody. Welcome to Beyond the Basics, Object Level Security. And we are going to, if I can get that correct title slide there we go. We're going to talk about some follow-on items from the first part of the series here, where we had covered some of the intricacies of what I call OLS, or Object Level Security. And we're going to talk today about that as a continued topic and introduced a few little kind of nuances or details that I think you should be aware of if you contemplate object level security. If you're just joining today, my name is Robin Tatam. I'm the Director of Security Technologies here at Help Systems, and it's absolutely a pleasure to be able to present to you. If you have any security questions pertaining to the content we're covering or anything around IBMI security, feel free to reach out. I am happy to answer those questions, or I have a team of people here that are extremely knowledgeable in various facets, not only on IBMI, but on a ton of different technologies. So hopefully you think of us in those terms. I covered yesterday the core components of IBMI security, and it was user profile, attributes and settings, a little bit outside the scope of object level security, but certainly influential. And we did touch on the all object special authority, which is a profile attribute. And so that's a big relevant part of all of this. System values also have a role to play. The default object permission, if you recall, goes up through a chain of command and ultimately reaches the system values. And then, of course, object authorities, where we are granting access or revoking access to various libraries or directories and the contents within them. I covered whether object level security would be the first step or the last step in your journey. Most of us think of it as the gold standard of IBMI security, and it comes with some pros and cons. Hopefully you guys all remember that. And my focus today is not necessarily where I want to call them cons, but let's call them considerations. Let's keep this a positive conversation. Now, the first item on this side of the equation is that object level security is not always considered the easiest concept to grasp. Now, there's no clear-cut yes or no to that. If you were on the session previously, I'll let you make the decision whether the concepts that I shared with you were something that you could get your mind around. You don't have to be experts just hearing it. Remember, I'm throwing 20 years of security experience at you in a very short window of time. So don't expect to come out of that with, a completely clear understanding. But if the basics were at least comprehensible, then hopefully that's an idea that you feel somewhat familiar with now. If you're completely in the dark, or if you weren't on that initial session, then certainly it's not going to probably be your first step, because there are some concepts there to get down. But we need to talk about some of these other considerations for sure. The inflexibility of the object level security model, whether there are other options that are at your disposal that may be more expeditious to implement, and the fact that object level security doesn't necessarily check all of the boxes. There are still some areas that we need some help with. So that's where we're going to focus today. The initial idea is that I want to share with you that everything in this platform, the IBMI operating system and everything within it, is integrated. In fact, that's what the I stands for. A lot of people say, why was it I series? Why was it IBMI? Well, now you know. Now, one of the items integrated into that is the infamous Db2 database. For many years, it didn't even have a name. It was just the database. It's kind of funny. I actually have spent my entire career in IT on this platform, starting back in AS400 days, as I'm sure one or two of you probably have too. And when I first started working with other operating systems, I kept asking, where's the database at? And it was kind of eye-opening to me that it didn't exist. And you actually had to purchase a third-party database. I'd just taken it for granted. I'd been an RPG developer. I was used to creating and working with physical files and never really understood that that was kind of unusual. Eventually, IBM gave it a name to provide some value associated with it, but it's the same fantastic database that it's always been, certainly with some key enhancements. But that's what that I is. It's all fully integrated, fully tested together. Now, if you're an admin, that's fantastic. But from a security person's perspective, like me, it's a bit of a challenge, because one of the things we have to acknowledge is if a person has access to the system and knowledge of some credentials, they can access that DB2 database through more than one interface, and they are treated equally. And there's lots of interfaces. Back when I started, it was a dumb terminal on my desk, a big clunky device, direct wire into the back of the AS400. That was all it could do. There was no network. There wasn't internet. They were all just pipe dreams at that stage. And really, in essence, it was after all of those things were born that we found ourselves struggling a little bit. The first thing I want to share is some good news, and that is that object level security works everywhere through all interfaces, no matter your connection method, whether it was designed as an application in 1988, possibly an RPG program that I wrote in my early days, or if it is Java or any other type of more modern interface, whether you're using the green screen, whether you're using Access Navigator, whether you're using a third-party tool, all of them will ensure that the user has the appropriate level of object level security. Now, I want to share with you a slightly more visual image that I put together to kind of describe object level security in visual terms. So here we have a user coming through a traditional interface. Typically, we refer to that as the green screen or 5250, but it is really a working method that has been around since the beginning of the S400. Now that connection is going to pass through object level security, as I've described. So if the user has permission, then they're going to be able to do their thing. If they don't have permission, the operating system is going to say, sorry, Charlie, you're not able to do that. And as a reminder, one of the slides that we covered in part one were the 4 key areas where users can gain permission. All object special authority. We have private authority. As a reminder, that was named or explicit permission to an object. We had public authority, which was the default assigned authority that's given to anybody who's not qualified or disqualified by numbers 1 or 2 above. And then lastly, we have a last gasp effort. It's a programming technique called adopted authority that allows us to include or introduce the permissions granted via the ownership or the owner profile associated with the application program, if there is one. So the question is, out of those 4 things, is access going to be granted? And in calendar 2021, every IBM system we audited, or not everyone, but certainly anyone that we audited that shared their data with us, fell into a few statistics here. So I wanted to share these with you because they are a little bit eye-opening. Now, don't tell my marketing team, but I'm actually giving you a little bit of a sneak peek here into the upcoming state of security study. So in 2021, there was an average of 244 profiles with all object special authority. Now, I've been putting the state of IBM security study together now for about 13 years, and that is the highest number, at least in recent years, and arguably since I've been doing it. So that's not moving in the right direction. Remember, all object is keys to the kingdom. Those systems also showed an average of 286 profiles that had non-limited capabilities. It's kind of a weird way to describe things, but if you recall, there is a parameter on a user's profile called limit capabilities. And if you don't implement that, you are non-limited, right? A lot of us think of it in terms of command line permission. It does control a few more facets of security than just command line permission, but I do acknowledge that is arguably the most associated and probably the predominant facet of that control. We also saw that less than 8% of all of the application libraries that we looked at had established a deny by default model, least privileged. And that means that they were not set to public exclude, right? So 92% of libraries say, as long as you have a user ID and password, public permission says you can come in the door. And 73% of those systems had no exit programs. Now, I haven't introduced the name exit programs before. We're going to talk about it quite a bit today, but exit programs are designed for a number of different things, but in the context for our conversation, they're going to help us monitor TCP/IP interface activity, right? The non-traditional interfaces. So what this really all adds up to is that object level security is arguably not frequently configured. And in that scenario, while object level security still steps in, it's basically saying anybody can do anything. And in that scenario, it becomes extremely critical that we implement compensating controls. Now, the good news is many of these compensating controls are already in use. When we talk about application menus, the application security itself, and any command line restrictions via that limit capability setting, you're probably sitting there very excited going, hey, Robin, we have all those things. We are doing that. And I'm not going to question that for a moment, because those are the predominant security controls that the vast majority of the IBMI community bets on the bank, right? And they still work today. I'm not dismissing the value of those compensating controls, but it's important to understand that they are indeed compensating controls. Object level security is not really putting up much of a fight. I don't know how well it's represented. I graded out. Hopefully that shows in the screen share, but it's still there. It's just really not going to do much blocking and tackling, right? So these green ideas are really what we are basing our security upon. Great. Well, maybe. When we introduce the idea that users can come in through non-traditional interfaces, we find a slightly bigger problem, right? These users, still identified through a user ID and password, are not going through the traditional interfaces compensating controls. There is no menu to an FTP session. There is no command line restriction to certain interfaces. So all of a sudden, these non-traditional, alternate, PC-centric interfaces, whatever you want to describe them as, are coming up. They're hitting object level security, which is basically taking a siesta, and the user is able to connect directly into the database or run a program, right? So they're not bypassing object level security. It's the fact that object level security is arguably transparent. So if you've ever heard of these and you've complained that IBM gives people all these backdoors into the system, in IBM's defense, they're not backdoors. They're just exploiting the fact that we cut corners back in the 80s and 90s, even the 2000s, by not configuring that object level security. Now, if this is your second session with me, then you maybe are buying into the idea that object level security is a great control, and good. That was my intent with our session earlier. I had shared with you that there are some authority templates provided by the operating system. I had a whole bunch of exits, and I thought what I'd do today is just break it down a little bit and make it a little bit more visual, because really we're not interested necessarily in the individual granular permissions now. We're just looking to see what can a user do based off of these different templates. Starting with no permission at the bottom, that's the ideal deny by default that I promoted heavily yesterday. In this instance, then, when we go up to use permission, which a lot of people used to think of as kind of the holy grail of object level security. Yeah, the users can see stuff, but they can't change anything. It's all protected. But what we've got to remember is that that still is going to allow some negative types of actions. When we go up to change permission, or the change template, now we can modify the contents of the object. And when we go up to all permission, we add the ability to maintain the object itself. All right. Now remember, the ability to change and delete data falls under modify. It's the actual object maintenance that's the black there. So the ability to change the settings on the object or blow the object away in its entirety. But even with modify permission, that default that IBM sets, we're still able to flush the contents of a database file. In slightly negative terms, these permissions equate to not only the ability to see it, but arguably therefore to steal it. Seeing something means I can download it, I can copy it into a duplicate. The ability to modify the contents means I can theoretically also corrupt the data, and the ability to maintain allows me to destroy it. Again, just as a clarification, modify lets me destroy the contents, but it doesn't let me destroy the object itself. Arguably, the damage has already been done. Who cares if they're deleting an empty file, right? So this means that we have to consider a compensating control on both sides of the house. Traditional, you've probably got a pretty good handle on. Non-traditional, I know from the State of IBMI Security study that 3/4 of you don't have a good handle on this. So it's an important concept that you grasp. If the term exit point or exit program is new and you've not heard that, or you're not really familiar with it, or if you know you don't have exit programs as a compensating control, this could be one of the most important facets of IBMI security that you're going to face, right? Again, object level security is not being bypassed. If you have good object level security, if you came out of part one, session one, and you said OLS is the way to go, kudos to you. It absolutely has a fantastic role to play in all of this, and there isn't a single interface that is going to bypass that. So it comes across as the answer to all of your prayers. The thing we have to remember, however, and this is a wake-up call for those people that have engaged in object level security, is that it tends to be a one-size-fits-all control or mechanism. What do I mean by that? Well, while most data isn't as secure as the owner typically thinks it is, if a customer does come and they can prove that they have good object level security, we have to consider these four considerations. Number one, the authority for the application objects, the files and the programs, is going to be applied to all user interfaces, not just the expected user interface. So if your user community is a green screen community, and that is the anticipated way that the application will serve the data to them, the operating system is still going to provide that same level of access, even if the user connects in an unexpected way. The operating system doesn't differentiate between those different access methods. So if you have read permission through the green screen, you also have read permission in ODBC and FTP. Likewise with change or all permission, and with exclude as well. So if I go, whew, lucky I knew that, I can now exclude the user from permission to read this data and change it. All of a sudden, the green screen application breaks as well because I've adjusted one single control and all interfaces are treated with equality. We have to recognize, even with great object level security, we are still lacking the ability to log those PC initiated requests. So if you tell an auditor that there is an FTP capability within the IBM, but sorry, I can't tell you who's using it, they're not going to be real happy with you. In fact, you may have encountered that already. So the inability for the operating system, even with great flight data recorder functions that exist, is unable to see the majority of actions performed through those network services. We've got a significant visibility problem. And number four there, last but certainly by no means least, even with great object level security, if you are relying heavily on restricting command line permission via that limit capability attribute, some of the PC interfaces that users have access to doesn't check that setting. If you don't believe me, log into an FTP session, type the word quote, Quote, leave a space, and type a command like create lib. And even if you are a limit capability user, there are some things that you can do. Now, there are certain commands that can be run, certain that can't, different interfaces adhere to that setting in different ways. So it's not a clear-cut thing, it's a bit of a mixed bag response, but at the end of the day, if you are basing your security on a user's inability to run commands, these interfaces are going to be your Achilles heel. Now, just to complete this diagram, my recommendation is that all of these things be layered together. Don't put all your eggs in one basket. Don't rely just on menus. Don't rely just on exit programs, and don't rely just on object level security. These things are synergistic. I'm a big proponent in the security world of layering security. It's kind of akin to what I call the M&M defense, where people rely solely on their perimeter firewall, only to find that somebody internally destroys their system, right? They never contemplated the idea that there could be users that make it through that perimeter, or users that you allow inside that perimeter that either accidentally or maliciously cause same outages as if it was an attack from North Korea, right? So we have to consider all of these things in unison, and therefore we will get the best chance of protecting our system. As I mentioned, there's lots of ways to see data. If you are a green screen person, you probably use tools like Query and DFU, maybe a third-party tool like DBU, but there's lots of different ways. A lot of the emulation tools have the ability to access information. This is the latest access client solutions, whatever we're calling it today, from IBM, provides a data transfer function, allows you to download a duplicate of the data to your hard drive. It lets you pull it up on screen, throw it into a spreadsheet, all things that are very helpful to the valid, legitimate users of that data, right? It's giving us some openness and the ability to use privileged or powerful tools. to slice and dice the information. But when used inappropriately, this is a huge security vulnerability, and it's super easy to use. I mean, a few clicks, even if you don't know the name of the file, you can click the browse button at the end of the box and go, there's my available libraries. And if I'm an application user, my user ID and password is likely going to show my production library in the list. Right? And I can just drill down to it. I don't have to know a whole lot. If I am more of a techie person, I might have familiarity with using interfaces like FTP through a command prompt. There's also run SQL scripts in various tools, right? So I can say select splat or update or even delete to the database. And it, again, is all designed to make the user more productive. But the assumption is that the object level security is currently in place and is going to appropriately limit how much the user can do. So if we expect them to see the data, but not delete it or re-engineer it, then we expect object level security to be in place, right? It's a little bit similar to the interactive SQL and the IBM operating system on the green screen. If you're not aware, anybody, any user that can run commands can type start SQL. And the operating system says, okay, what SQL statement do you want to run? And that can put the fear of God into people. The reality is IBM's expectation is that, yes, you can get into the tool, but the object level security will control what the user does. All right. And that maintains true. As I said, OLS is enforced with all interfaces. But if you don't have OLS, or if you don't have it tightly controlled, the ability for a user to step outside the boundary of the application becomes pretty pronounced. It's not just about pulling data, we can also push data. So FTP is a put statement. In data transfer within Access Client, there is a push data to IBMI. And there are update and delete statements in ODBC, JDBC, right? So there are all these mechanisms that are going to allow the data to be pushed back. And one of the things that I like to show people, just so they're fully aware, when I do, for example, an FTP transfer, it doesn't put any filter over it that says, the layout of this data doesn't really make sense. It just goes position 1 of the byte structure to position 1 on the file. So if I change the field order in a spreadsheet, or if I upload character data to a numeric field, we're going to corrupt. We're not just going to overlay, but we're actually going to corrupt. And with a single SQL statement, I can make that file unreadable. So these tasks are very easy to perform. It's also possible to do things at the object level, not just the contents, right? So on the left, I've got, again, a couple of FTP sessions. In this case, I'm renaming an object, a native object, and I'm also doing a delete. So we often think of these native objects as kind of in a separate world by themselves, but these PC tools still have access to them. And depending on a number of different moving parts and pieces, if you have not configured everything perfectly, then we have the potential that somebody can do damage even to our DB2 files or RPG programs and others, right? On the right side, I'm using Access Client again. In this case, I'm pulling up the contents of an IFS directory. Now, the IFS is a bit of a mystery machine for many people, but just know, think of it as the umbrella environment over the entire system. Under the IFS, one of the file systems is called qsys.lib. That is the native structure. It's the operating system. And under the operating system structure, we have all of your native applications. So any RPG programs, data areas, physical files. Think of application libraries. They are a subfolder of qsys.lib. And if I can drill down to the IFS, I can do deletes and renames in addition to the downloads and uploads that we've talked about. So all of these things are exposed, and you have to look at them holistically if you're going to have any kind of chance of protecting your system. I mentioned exit program, and I promised I would give a little bit of explanation in case that was a concept you had not been exposed to before. An exit point, let's cover that first. An exit point is a hook in an application that allows a programmer to attach an exit program to perform a function that the original application does not. In this conversation, the application is IBMI. It's the operating system itself. And IBM generously put a whole bunch of these hooks so that we smart programmers can write functions beyond the capability of the original OS. There are a slew of exit points throughout IBMI. attached to various things like creating a user profile or deleting an object. There's also a category of these exit points pertaining to PC connections over TCP/IP interfaces like FTP and ODBC. So IBM knew that our object level security layer in my little chart was probably grayed out. And so they said, we're going to give you some additional controls you can leverage. The exit program in this equation is what does the work. It's actually going to be invoked by the application, in our case, IBM I. It's going to be passed a whole slew of information about the request. In the case of a FTP connection, it's going to tell the exit program the IP address of the connection, the name of the user who is connecting, the function within FTP they're asking to perform, and even the information about the transaction, maybe the file name that they're trying to download or the command that they're trying to run. So the exit program receives all of this information and is responsible, arguably, for doing something appropriate with it, and then returning a pass or fail indicator. So there's a parameter on the exit program that gets returned to the exit point that says whether the transaction is being blessed or whether it's being rejected, right? And based on that pass-fail, the operating system will then continue that transaction on its journey, maybe to the FTP service, or it will tell the user that they're not allowed to perform that task, and it's actually going to shut it down. Now, it's important that I describe it that way because if the exit program says, yes, it's okay, that's not a guarantee that the transaction will be performed. For example, if I tell the system that I want to delete an object through FTP, the exit program can say it thinks it's okay with that, but ultimately I still have to have delete rights in object level security. The problem is most of us don't have those object level security rules. Now let's assume that I do for a moment. There's still another function that I need the exit program to perform for me, and that's the audit, the oversight of that connection. These PC connections, as I've mentioned, don't create very good logs. FTP has no log. So when somebody downloads a file from the system to their PC, there's no way for you to know that. Now, if they try to grab a file they're not authorized to, the operating system can tell you that. But if it is an authorized, well, at least an approved transfer, then the operating system won't create a breadcrumb trail that the user perform that task, which is a regulatory violation immediately. All right. Now, the exit program could be malicious. I don't want to scare you, but the exit program is written by a programmer. It can do anything. So we're going to assume, for argument's sake, that this is a legitimate function written by an application programmer who was told or instructed to do this, and that they have created code that is supporting the security efforts of the organization, right? But just remember, the exit program can do anything. So when we take a look at security on a box and we inventory the exit programs, if we find an exit program on just one or two of the about 30 different exit points, then that's a bit of a red flag because it's usually indicative that somebody wrote these programs themselves, and we want to be very clear on the role and function of that program to make sure it's working appropriately. All right. Questions around this, feel free to post them in the question panel and I'll circle back around to it. So these exit programs, in my opinion, are absolutely a base requirement for good security hygiene. They're designed to compensate for and reduce the risk associated with that poorly configured object level security and other poor security controls. We want it in order to prevent unwanted access to data and commands, and also to allow beneficial and approved access to continue. Because if your knee-jerk reaction to me describing this concept is, but Robin, I can't shut down FTP or I can't block all of FTP traffic because we use it for legitimate applications. The answer is yes, and that's a good thing. Those interfaces are great as long as they're being used appropriately. So the exit program can be selective about what it allows through. So I describe it as a firewall, more of a transactional firewall than a traditional firewall. It's not looking for packet anomalies. It's not checking for denial of service. It's basically saying, okay, R Tatum, password X134 ABC, let's make sure you're using FTP appropriately. Now, if you use this for a compensating control. That's understandable. But if you do invest in object level security, or you have an application that has deployed a good model, understand that the lack of visibility to these connections is still not going to be addressed by object level security. So the compensating control is still augmenting OLS by giving us the visibility to log an alert potentially on those connections. Now, you've probably noticed the little blue splat over there on the right-hand side, and that's a critical part of the benefit of exit programs. Remember when we showed the traditional, non-traditional interfaces coming in through those lines, and I put the little clamp to show that we can squeeze it based on a compensating control? It's very important to basically note that the compensating control is invoked before the operating system does any validation of the user capabilities. In other words, we still have preemptive capability to block or restrict a user, even if we have given them carte blanche to the system. Even if that user has all object, whether we want it or not, we just don't have a way to clean it up or do it quickly. The exit program can say, sorry, Robin, I don't care that you have all object. You've been explicitly told you can't FTP this file out of this library. And the exit programs will check that box for me. And it's a fantastic capability, because one of the things that allows me to do is set different access levels for different interfaces. Read it through green screen, change it through ODBC, no access through FTP. And it's giving the operating system some variety and some flexibility where traditionally it is extremely rigid. Object level security is a fantastic capability, but it is not flexible. Nobody would ever describe it as flexible, and exit programs can give you that. All right, so you guys are all convinced, I know it. How do you get these exit programs? That's on the forefront of your mind right now. Well, you've got two options. One, you can write your own. I did just check this link, so it's a slightly different color. I wanted to make sure it was still a valid link, but IBM provides a few samples online. The linked example here is for an FTP exit program. If all you want to do is put a wall around your system, basically block all traffic, I would actually encourage you to write your own. Those exit programs don't have to do a lot of deciphering of the request. They just say, set the return code to fail, end program, right? So very simplistic. Even I could code that. That is arguably where we get into a discussion about what if we're not going to simply block all traffic, that we want to be selective. There are considerations around performance, in which case, if we have that type of conversation, we need to be selective. We have high volumes and we're concerned about performance. Then arguably we go into option 2, which is to look at this as a commodity, purchase it as a commercial solution, and don't try to write it yourself. If you do go the self-write option, make sure you're testing every time there's a new OS release to make sure it still functions, and acknowledge if you are subjected to a regulatory or legal mandate, that auditors who may look at your system, if they know enough about exit programs, which they are quickly learning about thanks to the CIS benchmark, they will likely take exception to the idea that your own programmers wrote the programs to control access from, let's face it, probably the programmers. All right, so commercial solution tends to be a better option in this case, but I wanted to be fair and share with you that you can write your own. It's just not something that most people endeavor to do for a slew of the reasons that I've listed here. All right. One thing we acknowledge with data in an IBMI environment, arguably in any type of database environment, is that it's not always created equal. We use the term data classification to help us identify a sensitivity level associated with a particular element of data. For example, social security number here in the US. You may have a national insurance number in other countries, right? Credit card numbers, that's a worldwide thing. And other types of very private information is something that's going to have a much higher data classification than perhaps the run date of a particular posting function. Right? So there's going to be sensitivity levels that we want to apply. And the benefit to you in spending a little bit of time to classify the data is it's going to reduce the initiative's effort on the back end, right? There's probably a lot of info on your IBMI. Think about how much disk you have and the percentage of use of that disk, right? If you've been on the AS400, iSeries, System I, and all the platforms preceding IBMI, and you just keep rolling those applications forward, Imagine how much data you've collected over 30 years, right? If we have to secure all of that as if it were all equal, it's a bit of a Mount Everest of effort. If, however, we can identify that there is elements of data that should take priority over the vast majority of that disk usage, then we can more accurately focus our attention on the things that warrant that attention. All right. Now, an example of that type of classification may break down into public knowledge, right? Things that we're not going to expend any effort around. It may go up to sensitive or internal use only. We may then go up to confidential, which is maybe some financial information. That may even fall under restricted, where it is not only just people internally, but it is a very small subset of internal employees, right? And so by focusing our attention initially on that, we can narrow the scope of the effort involved. Encryption has become extremely popular, even in IBMI's world, where we often don't talk about these things, but IBM enhanced the database and provided a capability known as field procedures back in version 7.1 of the operating system. I almost removed the reference to 7.1, but occasionally we have people that are running older OSs. So as long as you're on 7.1 or newer, you have access to those enhancements automatically, and the field procedure concept is something that exists within your OS version. The purpose of a field procedure and the database enhancements that were created to support them is designed to facilitate more seamless, transparent encryption for existing data. Now, I had the honor back in the mid-2000s of being invited by IBM to participate in the Red Books on IBM encryption. I like telling my kids I have a book on Amazon. So it was a book that took us about 6 weeks to write. It was a lot of effort, manual work to encrypt data in IBM at that time. It was around 5.4. The new release was coming out 6.1. But I concluded out of that residency at IBM that nobody in their right mind would incorporate encryption into their own application. The only viable way that was happening was if the reader was working for a software vendor, right? Where you're doing that effort once, but lots and lots of organizations are benefiting from it. Nobody was going to do it in a homegrown application. 7.1 came around, and arguably we could throw that red book out the window. There's some great concepts in there. Download it, give it to somebody for Christmas. But arguably now with 7.1, the reality is we can cut corners so much more effectively than we could back then, to the point where this is now a viable option. If we look at data within a DB2 file, we're going to see that data in its raw form. Don't care what tool you use. This is just pulling up an RPG application that is looking at data that comprises some sensitive data as it exists in the US. Credit card, you understand. Social security number is a special individual identifier here in the US. Bank number, credit limit, those are all things that I think everybody can relate to regardless of your location. And in that instance, obviously that data is exposed. Object level security might prevent me from seeing the file, but if I've been given green screen access to see that data here, I've also got the ability to FTP it onto my PC, right, and walk out the door with it, so that that use access that I mentioned earlier that was often desired is still going to leave us a little bit exposed. Now, when we look at that data in an encrypted form, we get a much more robust form. I can still see the name in this instance because I've indicated that that is publicly viewable information. Public maybe based off of the user of the application. But the employee ID, the credit card, the social security, the bank number, and the credit limit have all been replaced with kind of markers there. That's sometimes a little bit strict, but so maybe we look at this in a masked view. This is that same application, and in some instances I've highlighted the social security number, but based on the fact that we have some international folks here with us today, let's look at the credit card, right? PCI allows us to expose parts of the credit card number. They actually allow us to expose quite a lot of it, but I'm sure when you've called in or you've received a statement from your bank and it says the last 4 digits of your credit card are, right? That's because PCI allows disclosure of that. So within encryption, it can be very beneficial to give this partially viewed or masked view so that we can still leverage the data without having complete exposure and creating a violation for that regulation or mandate. The good news about DB2 encryption, when we use field procedures, is it doesn't matter how we access the data. So it's not the program, the application itself that's saying encrypt the view or decrypt the view. It's actually in the database, and that was the enhancement in 7.1. So here we have, I don't know if it was an SQL view or a Query 400 view, but even with this raw tool provided by IBM, it's adhering to the rules associated with the encryption. If we get into some alternate tools, Help Systems has a tool called Navigator, not to be confused with the client access tool, Access Client Solutions. But in the tool, it gives some SQL function. And so we're able to show the credit card in a masked view, the social security number in a fully encrypted view. So regardless of ODBC, JDBC that this tool rides on, I'm still protected. Even in a DFU, right? The rawest of the raw tools. Data file utility, which if you're a programmer, you probably live and die by. This tool is going to adhere by it as well. So it's effective regardless of the interface, which is a really important aspect of encryption. We don't want to use it just to write their own RPG program and circumvent the encryption function. As we had with exit programs, we have two options here to encrypt data at the field level. The first option is the DIY approach. You can write to IBM's APIs. I've listed here a whole slew of them. I'm not going to go through them all. You can read them or glance across them. The bottom line is it's a handful, right? It's not something that you are going to have done by 2 p.m. Thursday, but it is definitely something you could do if you're a glutton for punishment. Now, the key management is included in the operating system. You have to be careful if you plan to do anything with your own key management. It may not meet a regulatory mandate. IBM has some good key management in there, but it then means that I have to kind of integrate that into my application. Right? There's a few ways we can do this. The field procedure function is actually an enabler. It's actually not dissimilar from an exit point on a field. It allows us to invoke an exit program. The exit program is the field procedure, right? It's what actually will do the encryption or decryption based on criteria. So you still have to write the field procedure, even though the operating system was enhanced to support your field procedure. Option 2 is, again, commercial response. We have a tool called Powertech Encryption for IBM. It gives you all auto generation of the field procedure. It has all the key management in it. So it's an option that you have. Obviously, there is a financial cost associated with that, but when we factor in some of the challenges of the DIY approach, it's usually a much less expensive option in the long run. All right, malware. I know it's somewhere in a discussion in your shop, even if it's not pertaining to IBM. So let's dispel a couple of myths. Number one is that a virus can't hit this box. Well, it is true that a virus cannot infect or encrypt anything in the native library structure. So your physical files, your RPG programs are fairly well protected in that regard. So for once, if you're still running a green screen application, you have an advantage, right? But we have to acknowledge that a virus or malware can destroy other file systems under the IFS. So the native side, what we refer to in IFS terms as qsys.lib, has a pretty good defense mechanism, but other file systems don't. But we've also acknowledged that malware can still impact even the native structures via a rename or a delete operation. Right? I showed you a little bit of that when we were talking in terms of the exit points. So I can write a script that says delete all the physical files in the library, and I can do that. They won't be infected, but they'll be gone. If you're doubting what I'm saying, or if you have ever exclaimed that it's okay, we're good on IBM, this is a screenshot that a customer provided to us after we scanned for viruses throughout their IFS. where we discovered actually about 500,000 viruses. In this case, there was some cleanup that was done before they scanned. And so it was about 248,000 copies of an infected file. It was self-replicating. So it does happen, and it happens more often than you think. And we've talked about these authority shortcuts multiple times, so hopefully you're starting to memorize this now. Again, looking at the bottom, the steal, corrupt, destroy, we have to be considerate of the corrupt and destroy when it comes to this, right? When we talk about the types of objects that malware can impact, this is a screenshot out of IBM Navigator for I. There's a very good chance that you have this on your system. It's part of Access Client Solutions. And in this case, I've pulled up the defined drive shares to my integrated file system. Now, if you look at this and you go, Robin, this is not a good example, I certainly acknowledge this is not an idyllic example. There are a couple of shares out here that, well, more than a couple, but two for sure, qsys.lib and especially root, that are a big no-no. So this is a test system in our environment. We see root shares quite frequently. So if you pull up your list of drive shares within the integrated file system and you see root in the list, we need to talk, right? Because that means a user through Windows can map a drive into your IBM I starting at the root folder, which is the parent of all parents. Renames, deletes are possible, right? So here we see a rename of a native object, we see a delete of a native object. On the right-hand side there, we see a view through Windows Explorer where at the bottom, I have a root mapping mapped into a system on my box, right? And so it gives me access to those things. The IFS is a whole conversation in of itself, but let me share with you a few tips that we cover when we talk about IFS security. If you're interested more in this, we do have some content around the IFS. It is a popular topic, and we know that, so we do have some information out there that you can learn more. Big thing, if you are not using a service and it supports starting or stopping it, shut it down. Be careful that you don't shut it down without first understanding if you are using it, because that would be a little disruptive. But there are services that we can shut down, including the ability to map drives. There is an exit point. The exit program solution that I talked about in the first part of this would actually give visibility through the auditing function of the traffic coming through those drive shares. So a great option for determining whether the IFS structure is being used in your shop. And then you can determine, do I want to simply shut this down? The exit programs, again, come into to play a role here, the ability to restrict through that rejection, as well as log activities pertaining to IFS information, very helpful. I can decide that Robin can map a drive, but can't go through the folder called X, or they can read data from a stream file, but they can't write to it, or they can't delete it, right? So the exit program is going to give us nice control there. I mentioned the big no-nos of sharing the root folder and qsys.lib, so check your system. If you find that, let's talk. It's definitely one of the quickest, easiest things you can do to reduce risk. There is a special authorization list. If you sat through session 1, authorization list is a name you should recognize. It controls the behavior applied to objects. Now, this is a slightly different authorization list. This is a special one. I've had customers come to me and say, Robin, I looked at the authorization list and it says it's not controlling any objects. And that's true. This is a special name, QPWF server. It's reserved. It's on your system. You didn't have to create it. This is controlling whether a user in the root folder can drill down into qsys.lib. My suggestion is consider setting that authorization list to public exclude, which means people cannot drill down through qsys.lib. Do not, as one customer did, change the permission on the qsys library. That's completely separate. That will break things. This is an authorization list. If you find that there are users that need to have exceptions, John needs to connect in through qsys.lib to do something for system maintenance, okay, then add them to the authorization list with a private authority, concepts we talked about a lot yesterday. Bear in mind, however, if you like the idea of the QPWF server and you implement it, it is ineffective against all object users. Yet one more reason we don't want users with all object, because that's the keys to the kingdom. The authorization list thinks the user is perfectly okay because test 1 in our list of 4 is whether the user has all object. Turn auditing on. Make sure that you are using the flight data recorder to pick up if there are failed connection attempts, okay? Also use auditing if you have sensitive objects in the IFS. A lot of times people have a ton of files, maybe there are some sensitive objects there. You can audit at an object level and take advantage of that in the operating system. Now, logging those events is important, but so is monitoring the logs. So if you are just recording the events, yeah, it's better than nothing, but if it's going in a black hole, one could argue you're not really squeezing a whole lot of value from it. So monitoring the audit log is helpful. There are some very rudimentary ways to do that in IBMI, otherwise third party tends to be the way to go there. And ultimately, protecting the IFS should always entail getting good backups. Now, one could say that that applies to the native side as well. But again, if you look at the IFS as all encompassing, including the native side, then having good backups within the IFS pertains to that as well. Don't wait till a disaster occurs to test to see if those tapes can be restored from. Have a recovery plan. You can rent IBMI partitions from various companies around the world. Rent some space, try a recovery, or have a test LPAR. Make sure that you know the nuances, because you will discover some failings, I can almost guarantee it. And rather than try to figure out how to address those failings as the place is going down in flames, you want to have all of those boxes checked ahead of time. Right. Now, if you're sitting back with your feet on your desk and saying, Robin, don't worry, we got high availability. Understand that when it comes to, especially malware, but any type of inadvertent act upon an object, native or IFS, high availability has one purpose in life: to make your backup, your secondary system, look exactly the same as the primary. So if I delete a file from the primary, or I infect a file on the primary, a split second later, high availability will take care of infecting or destroying the system on the secondary side. And there's a question that I always ask people, whether the DR plan that you have accommodates a scenario whereby both the primary and the secondary go offline for the same reason at the same time. And I rarely get a affirmation that it's covered that, right? High availability is great, especially for hardware failures. I'm a big believer in it. We have Robot HA in our portfolio, right? We also write Power HA for IBM. So there is lots of belief here within help systems as to the credibility of this capability, but know its limitations as a general topic. Mirroring a system when something bad happens is going to cause a problem on the backup machine. So how do you scan from malware? Well, I'm not going to give you two options this time. I'm only going to give you one, and that's a commercial response. Help Systems actually has an antivirus for IBMI. It's the only commercial powered engine. It was written by McAfee. It's maintained by McAfee, but McAfee doesn't know what a power server is. We do, so they give us the source code and a big fat disclaimer, and we make it run natively on IBMI. We also run it on AIX and Linux, and we can run it on Z and other things. So very comprehensive solution. We're here to talk about IBMI, so I'm focusing on that, but it is an expansive conversation. The beauty of this is that IBMI has Antivirus Infrastructure built into it. They added that in version 5.3 back in, what was that, 2003, 2004? But the infrastructure does nothing until you add the engine, at which point all the infrastructure wakes up and says, oh, great, you plugged the engine in, let's go. And you can do on-access scanning, you can do scheduled scans, things like that. If a file is deemed infected, it can quarantine it, it can cleanse it potentially. So there's a lot of great value here. And that's a virus on the eye. It's also now got functionality that allows us to look for activities that are originating off the eye that are indicative of ransomware. All right, so if your fear is your laptop getting infected and using a drive share to start slamming objects in the IFS, we can pick that up too. So it's a really good comprehensive solution, and one you should take a look at. All right, we covered next steps yesterday, but just as a recap, determine if object level security is an appropriate mitigation response. Right? That includes these other things. So object level security always has a role to play. It's just how big of a role is it going to have? If you want to commit the time and effort to really manage your system well and use object level security, I'll be your biggest fan. but I also know that I would rather you do some other things that can be implemented quickly and effectively rather than chew on how to do object level security for the next 5 years. Download some resources. Current state of IBM iSecurity study is on the website. It's a free document. We publish that every year. So each time we release it, we publish it on the website. We typically do webinars around it as well. So keep an eye out for that. Take care of downloading the CIS benchmark. The CIS benchmarks give basic best practices around different operating systems, devices, and there are now benchmarks for IBM I, as long as you're on version 7.2 or later. Those benchmarks are free. They are publicly available, which means that not only you can see them, but your auditors can, so they're getting smarter. And so can the bad actors. They're getting smarter too. So I would offer that you should get there first. When you have all these mitigation activities kind of percolating around on your desk, prioritize them, right? You're not going to be able to do everything. You're certainly not going to do everything all at once if you have any intent of being successful. So assign goals, make them measurable, and throw some good timelines at it, right? Standard project management type of tips and techniques. If your team has the expertise to do all that, if they have the time available to do all that, fantastic. If they don't, then partner up with outside experts. And there's a few of them out there, not a ton, but there's certainly a few. We're happy that we have a bunch of those people. We're not exclusive in that if you're looking at operating system expertise, but they either work for help systems or I know who they are. So if you're interested, feel free. We're not just a software vendor. We have people that know the operating system as well. I mentioned, and I omitted it off of the slide just now as next steps. I mentioned this yesterday, but we also do kind of a review of an IBM I system. I mentioned this was free. I forgot to throw up the poll, so I'm going to do that now for everyone. In fact, while I'm talking, why don't we do that? If you are interested in running one of these reviews of your system, it creates about a dozen pages in the document, and out of that, we'll hit about 7 different categories of your IBM I. There's no cost to the review. There's no cost to use the tool to scan it. You can run it as many times in a week window that you want. And the document that comes out of it is yours. You can distribute it, you can shred it, you can stick it up on your bulletin board, although you might not want to do that unless it's all green, but it's yours at the end of the day. If you've run one previously, but it's been, let's say, at least a year, let's run another just to get a refreshed view. And from here, you'll get a good feel for where you are with your library permissions. How many users have all object? Do you have any exit programs? And is there an antivirus installed? So a whole slew of things that have been in the conversation today will be able to apprise you of your success or failure in that particular area. And then obviously, if you want assistance in mitigating it, we can do it or you can do it. All right, just about 10 more seconds. I'll let you answer that if you're just grabbing that, and then we'll close out here. My next slide, I'll give you a sneak. I'm just going to ask if there's any questions. So if you do have questions, feel free to use the question panel. Got about 2 minutes here by the looks of it to answer that. Let's close the poll out. And I do see a couple of questions or comments. So Steve, you were reminiscing a little bit about the legacy of the box, as many of us do, but you made a comment, don't forget all object profiles that are shared. Talk to me what you mean by shared. You got a profile that multiple people are signing on to, or you have a profile that's a service account? What do you mean by that? Maybe you can help me. So John, we use an encrypted ASP for your PII and PHI. For those of you not familiar, personal health information, personally identifying information is what that stands for. Data is encrypted at rest. How would field encryption work in that scenario? Okay, so encrypting your data on the disk is good. It's a good start. It's actually been around for quite a while. Here's a scenario though where field level encryption is going to actually be a better answer. You have all data encrypted on the disk. Any request I make for that data, automatically decrypted. I don't care if it's a DFU, a DBU, an RPG, a copy file, a display physical file. The disk is decrypting the information simply based on the fact that there is a request of that data. It is not based on who the user is, and it's not going to give you a masked view. So disk encryption is good to protect you against arguably one primary thing, and that's someone taking your disk units. Now, within IBMI, we have to recognize that stealing a disk unit is not as easy as it is in Windows. First of all, I got to get to it. But even if I can pull one drive out, it has data scattered across it. So it's not going to be a complete picture. And if I then plug it into another IBMI, if I have one, it's going to tell me first thing you have to do, format the disk unit, right? So lost disk units, unless you're turning them over in a set for recycling or something, arguably not a major risk to us in the IBMI community. It checks the regulatory box. So you've probably got a mandate, I'm guessing, talking about RHI or PHI or PII, and it checks the box. But I'm a believer in field encryption. The good news is you can do both. Arguably it's double encrypting, but the disk encryption is pretty non-invasive. So encrypt it in the field, in the file, and then throw it on the disk, which is encrypted, and you get the benefit of both worlds. All right. Let's see, Dan asking RCAC or encryption. RCAC is row column access control. It is security at the field, record and field level. So think of it as object level security on steroids. So the first thing is you got to get object level security done. What I tell people is RCAC is great. Most people are not ready for it. If you still have a password length of 1, and yes, we did see customers last year with a IBMI, multiple IBMIs with a password length of 1. Get your system secured, then get your library secured, then get your object secured, and then we'll talk about RCAC. It is not encryption. It does have the ability to mask the view for the user, so it does confuse people, but encryption is actually at rest in the disk. It doesn't matter what view you put onto it, it will apply. So there's a little bit of a gray area in between. Again, not mutually exclusive, take advantage of both. All right, I'm going to wrap up here. I'm going to say thank you. I know we're a couple minutes over. I know there's a couple of other discussions, and I will actually hang out a little bit longer. So if you asked a question, stay online if you can, and I'll mention that. I appreciate the opportunity to present both sessions to you. That was a nice surprise, and I will be happy to answer any questions now, or if you think of anything after the fact, go to send a message to info@helpsystems.com, or I had my email address up earlier. So if you have that, tuck it away, keep it handy. And thank you for joining us. Visit helpsystems.com for all your IBMI security needs. Take care, everyone. We'll talk again soon.